All right, so we have dealt with factoring ax squared plus bx plus c, where a and c are prime. Now we have a situation where a and c are both composites. 4 has more factors than just 1 and itself. Luckily, it's a low square number, so it only has one extra factor of 2. And we have 15, which is definitely not prime, because it has factors of 1, 3, 5, and 15. So this is going to increase the options of us that we have to look at. So we go through our checklist. We look for a greatest common monomial. There isn't one. We look for a difference of squares, and you're going to tell me 15, let alone negative 15, is not a perfect square. And so we are stuck with finding a binomial pair of factors. So, Betsy, what is the table that I am going to set up?
The possible terms.
So we want possible terms. And linear terms. Okay, so inside my possible terms table, what am I now going to put in just to help myself get started? It's always hard to stare at a blank table or a blank page. Betsy? How many parentheses? Let's start with 4 pair. We may need more. There's a very real possibility we may need more, but let's start with 4, and if we need more, we can add more. Right, Henry? Okay. And notice how I'm leaving a little space just so that I can put in my rainbows and not go over my possible factors. Okay, possible terms. So what is the next question that you're going to ask yourself? Joe? What two things multiply together equal 4x squared? Do you have an answer to your statement?
There's a couple things we could do, but I guess I'd start with
2x and 2x. Okay. What two things can be multiplied together to get negative 15? Which is obviously the next question that you are asking yourself. Jenna? Negative 3 and positive 5. So we have negative 3, positive 5. So then I'm going to switch the order. I'm going to do positive 5 and negative 3 in the second one. And then I'm going to take the opposite terms. So instead of having negative 3, I'm going to try positive 3. So positive 3 and negative 5. And flip them. So negative 5, positive 3. Now, the nice thing here is, do I have any repeats? Do I have any repeated binomials?
Well, I think the second one and the fourth one.
Saying these are the same?
Yeah.
And it's nice that it worked out because we're using, because the reason why that happened is because 2x and 2x are the same. So the nice thing about this particular problem is the second binomial that we wrote out is the same as the first one. What can you say about this binomial and that binomial?
They're the same.
Yes, those binomial pairs are the same because, again, of the 2x. So I'm going to hold off on these. What other options might I put in there since we're looking for options? Joe?
1x times 4x.
Okay, so we'll try a 1 and 4. And so then let's bring this down. So we have negative 3 and we have positive 5. We'll flip them. So we have positive 5 and a negative 3. So let's go ahead and try to find our linear term. I'm not sure we're going to find it in these four. Just throwing that out there. So 2x times 5 is 10x. Negative 3 times 2x is negative 6x. I combine those terms and I get a whopping total of 4x. That doesn't work. Let's try this one. 4x times 5 is? That's 20x, isn't it? Okay. Uh-oh, I feel some. Negative 3 times x is? Uh-oh, check this out. 20x minus 3x is? And that's what we're looking for, isn't it? So we got really lucky, didn't we? Now we could have also tried, instead of 5 and 3, what are some other factors we could have tried for 15? Yes? Yes, sir? 1 and 15. So we could have had a whole bunch more options. But luckily, we got it sort of on our second go-around, which was really, really wonderful. So our equivalent expression in factored form is 4x minus 3 times x plus 5. And I am done.